In the last video, I covered the matches and looking at methods as well as the find method briefly. I show them here on this slide. All return a Boolean if the regular expression was matched in some way to the string. The matches method will match the entire string to the regular expression. Reluctant expressions may be greedy when used with this method. The looking at method will match from the start of the string. It doesn't have to match the entire string. This method will honour a reluctant expression if one is used. The find method is often used in loops to continuously find multiple matches to the pattern. Additionally, there is an overloaded method, which allows you to specify where to start searching. This overloaded version of the find method calls a reset before attempting to match. I finished that last video by printing the result of the find method after calling the reset method on matcher. This gave us the same result as calling the looking at method. In this case, I used matcher.start and matcher.end to get the matching substring. I can use another method called group to do this. I'll copy the matched on println statement and I'll paste that just below. Now I'll call group on matcher. Let's see what that gives us. I'll get the same result as the previous statement. The group method returns the subsequence of the previous match. This will change as I continue to call find. I'll set up a new example, first using a different string to match. I'll make this a text block with several HTML tags in it. I'll include a h1 tag and I'll make it uppercase and just put some text in there, so my heading. I'll add a closing tag for this and the other entries I'm adding as well. Next I'll use an h2 tag, lowercase this time, and make that subheading. I'll set up a paragraph tag and a second one. Lastly, I'll have an h3 tag for the summary. Let's say I want a list of the headers. So in this case, I want h1, h2 and h3. I'll set up my pattern for that by calling pattern.compile. My expression will have an opening angle bracket and then lowercase h and uppercase h in square brackets. I'm going to follow this with \d, which stands for digit, and I have to escape the first backslash with the second one. Next I need a closing angle bracket, then that will be followed by any number of characters. So dot asterisk. The ending tag will look like the starting tag, but I'll include a slash after the opening angle bracket. I'll get a matcher instance from that pattern, passing it my HTML snippet. Now I'll find matches using a while loop. I'll loop while HTML matcher.find returns true. I'll print the group, which is the matched sub-expression. Running this code now. I'll get my 3 HTML headers printed, but I'll also get the tags included. If I wanted just the text and not the tags, I could call the substring method on that text, of course, but there's a better way. Regular expressions provide meta characters in the form of parentheses to identify a special section of the expression called a capturing group. Grouping is a way to identify targeted parts of a regular expression match, often because you want to do some additional processing on that sub-expression. A group is enclosed in parentheses. A match to the group is said to be captured, meaning the text is stored for additional usage later. Capturing is a way to access the matched groups, called capturing groups, of a regular expression match. You might already be familiar with back references in some regular expressions, which are numeric references to captured groups. There are also named back references. I'll cover both of these types of back references shortly. The matcher class has methods that let us use both numeric and named references to access the captured groups. I'll put parentheses around the dot asterisk in my regular expression. This is the text within the tags and the text I want to capture here. If I run this now, I get the same output. When you call the group method without arguments, you're always going to get the part of the string that match the entire regular expression. If I want to get just the captured group, I'll need to use the overloaded version of group passing an index. I'll copy the statement in the while loop and paste 2 copies of it directly below the first statement. I'll first change the text that's printed, so I'll make the first to be group 0, and I'll pass 0 to the group method. For the second, I'll make it group 1 and pass 1 to the group. Let's see what that gives us. You can see that group 0 matches the first output. When you pass 0 to the group method, you'll always get the full matching subsequence. But look at what I get for group 1. I'm now getting the text that was captured in the parentheses, printed in each case. I'll comment out the first 2 statements and I'll remove the group 1 text in the last statement. Running this again, I'll only get the heading text printed out. That's kind of neat. I hope this gives you an idea of how easy it would be to extract the information you need from text or log files if you're proficient with regular expressions. I can only use this group method that takes an integer when I'm actually using grouping in the regular expression and can only use an appropriate index. Because I have one group defined, I can either use index 0 to get the whole match or index 1 to get the capturing group. I'll change that last statement and pass 2 to the group method. If I run that, I'll get an index out of bounds exception because there is no group 2. I'll add another group. Let's say I want to use the H level for some reason, so I'll wrap the first \\d in parentheses. This creates 2 capturing groups, but it has no effect on the matching. I'll next change my last statement to print both captured groups. I'll add HTML matcher.group and pass it 1, then a plus and a space between them. I'll add another plus and a new line after that, and then also print group 2. Running this code, you can see the digit is printed, which is the first capturing group, and then the text within the header tag, which is the second capturing group. You can name your capturing group with another special set of meta characters. This starts with a question mark and a name contained within angle brackets. I'll change my regular expression. After the opening parentheses, I'll put a question mark, opening angle bracket, and I'll put a name here, so level, and an ending angle bracket. I can reference this by level now when I call another overloaded version of group. So instead of passing one to group, I can pass the name of my capturing group. Running this, I get the same result as before. The end and start methods will all take either a group index or a capturing group name. I'll show you one example of this by printing the starting index of the current level in the string I'll call HTML matcher.start and pass that the capturing group name. I'll run the code. You can see the index of each of the header tags level. Before I move on to the replacement methods, I want to show you another handy feature in IntelliJ. When I place the cursor inside a regular expression, like here, in HTML pattern, inside the square brackets containing the H letters, notice I've got the light bulb icon on the left-hand side. If I hover my mouse near the gutter, I can click on that, and IntelliJ will present a list of options, one of which is check reg exp, which is of course an abbreviation for check regular expression. I'll click on that. I get this little pop-up, which has my regular expression in the top input field. This pop-up lets me test different strings by typing them into this sample field. IntelliJ will then tell me whether the string entered matches the regular expression. I'll type in the opening tag h1, sample, and the closing tag h1. You can see the green check mark, which means this sample string is a match on this expression. Now let's see what happens if I wrap this inside a body tag. So I'll add a start body tag at the beginning of this sample string and an end body tag at the end. I still get the green arrow, meaning there was a match, but you can see by the grayed out area that it was a partial match to this string. If I change the h1 to head now, IntelliJ gives me a little error icon, so my regular expression didn't match anything in this text. This is a handy little feature if you're trying to figure out what's wrong with your regular expression or it's not matching when you think it should. In other words, a quick interactive way to check your regular expression. Okay, so I'm going to end this video here. In the next video, I'll be showing you a few more methods on Matcher, which lets you replace parts of your string, swapping subsequences with replacement strings. See you in the next video.